distribution of this area so that this area is also a square, but now I have changed the distribution about the axis. Now the moment of inertia of case 1 and case 2 will be different. Moment of inertia of case 2 will be greater than 1 because the area is distributed far away from the reference axis. So moment of inertia will depend on area, the axis, and how the area is distributed about the axis that you are talking about. So please keep this thing in mind. Now, how are we going to calculate? Now, in our questions, there will be two types of areas, one involving regular geometric shapes and other involving curvilinear shapes. Today we'll focus only on the regular geometric shapes and tomorrow we'll bring in the curvilinear shapes. Okay. Now, in schools, we had derived some formulae. I remember having done in school for a rectangular surface, moment of inertia about the axis. So there are derived in physics for moment of inertia, based on the shape and the axis chosen. So what we have to do is, in ship stability, whatever shapes are used in our questions, we shall learn some standard formulae of moment of inertia. We will not engage in the derivation of them. There are some formulae which we shall learn and we shall directly apply them in our calculations. What are the shapes that we usually use? There are 5 shapes usually that we use. So we need to recall and use the formulae for moment of inertia of regular geometric shapes about standard axis. And I remember very clearly, at least I had done it in the school when I was in class 9 or 10. Some of these we had derived in the school. The regular geometric shapes of interest to us, as far as our exams are concerned, are rectangle, triangle, then circle, then semicircle, and the quadrant. These are the 5 regular geometric shapes which could be part of our questions. So we shall learn some formulae for these shapes, formulae for their area. So we'll learn 3 things out of it. First, what is the formula for the area? 2, where is the geometric center of that area? And third, some MOI formulae about some standard axis. So 3 things we'll learn. We'll start with rectangle. I have already, so you don't have to waste time in noting it down or something. The formula that follow, I have already shared with you a PDF document. You can refer to that, no problems. Rectangle. If you still want to take it down, you can take it down. We know this is the shape of the rectangle, guys. Let us say this side is L, this side is breadth. For a rectangle, when I ask you in questions, where is the geometric center? Your answer would be intersection of the diagonals. Where will be the geometric center? What is the area of a rectangle? You all know, I don't think that is a question to be discussed. Length into breadth. Where is the geometric center of this rectangle? Your answer should be intersection of the diagonals. That means I draw one diagonal, I draw another diagonal. Where the two intersect, that is the geometric center. The geometric center is the intersection of the diagonals. Then, what are the standard axes about which we have to learn the formulae and then put them to use? One, we'll learn about this axis. Now guys, you can name these axes whatever you want, doesn't matter, okay? I have named it XX. What is this axis? How do you explain this axis to me? Suppose this diagram was not there and I want you to draw this axis. What will I say? XX is an axis passing through the geometric center or the centroid of the rectangle and parallel to side L. Am I right, guys? XX is passing through G and parallel to L. Does that describe XX correctly, class? Yes or no?
Yes, sir.
Correct, beta? Okay. What is the moment of inertia of this rectangle about XX? You see, I have written in the subscript the axis here, IXX. It is LB cubed by 12. Length into cube of the breadth divided by 12. Another axis about which we will learn the formula is this one. I have named it YY. Naming is not an issue. How do I describe YY? It's an axis passing through the centroid and parallel to side B. In this case, IYY will be BL cube by 12. Which side is being cubed? Just to aid your memory, just to help you recall it better. In each of these formulae, the side which was cut by the axis is being cubed. The side which is, so in the first case, breadth was cut by the axis, so it was B cube. In the second case, the length is cut by the axis, so it is L cube. So LB cube by 12 and BL cube by 12. But please remember, both these axes are passing through the centroid. Okay, so these will be the two formulae which we'll be using and apply further in our application. Any questions on these two formulae, the area of the rectangle, the location of its geometric center, XX and YY, right, guys, and IXX and IYY? Any questions?
No, sir. All clear.
Okay. Those of you who are not on mobile can go on their WhatsApp also. And the last document I have shared, in that this rectangle slide is there. Can you see that, guys?
Yes, sir.
Yes, sir.
Okay. So whatever is on this slide is there with you already. So don't worry about it. Okay. Now we go to the next shape, the triangle. Now, guys, triangle, before I talk of triangle, I know in phase one, some of you in grain stability, in GZ curve, I have done it. Guys, at every triangle, when you say area, you say the area of a triangle is half base into height. Now, which is the base, which is the height, which is not said here clearly, but is automatically understood, is that it is the height corresponding to this base. So whichever, now any of the three sides can be taken as base. A can be base, B can be base, C can be base. Now, depending on which one have you taken as the base, your height has to be corresponding to the base. Okay? Because the area is half into base. So if you change the base from A to B or B to C, then height cannot remain same. Please understand very clearly. Okay. Now, if somebody wants to take C as the base, let us say this is base 1. Then the perpendicular distance of the opposite vertex, let us say this is A, B, C. Opposite vertex is A. The perpendicular distance of the opposite vertex from this base is the height corresponding to base 1. So the area of the rectangle will be half into B1 into H1. Now, another guy may say, no, in a given situation, sir, I can't use this as the base. I want to use side A as the base. Somebody may say, I am using this as the base B2. If B2 is the base, then what is the opposite vertex? C. You drop a perpendicular from C onto this, and this will be the height corresponding to base 2. So then area will be half into B2 into H2. Obviously, it's the same triangle, so both these areas will be equal undoubtedly. Likewise, if you take the third side as the base, you will have corresponding height. Is the concept of base and height of a triangle clear, guys? Yes or no?
Yes, sir.
Anybody has any questions on the concept of base and height of a triangle, guys? Because then in the questions unnecessarily will go into spin, which can be avoided. Okay. Okay. Now, another thing is, where is the geometric center of a triangle? In schools, we have learned that geometric center of a triangle is at the intersection of its medians. What is the median? If ABC is the triangle, find the center of BC, join it with A. This is one median. Find the geometric center of AC, join with B, another median. Find the geometric center of AB, join with C, third median. All the medians intersect at one point. And we also know, some of you will be able to recall, that the distance of the geometric center from the base is one third of the height, and from the vertex, it is two-thirds of the height. Now, guys, which base and which height, depending on which base are you taking? Suppose I'm taking this as the base, then this is my height, guys. This distance will be one third of the height. This will be two-thirds of the height. If somebody says I'm taking this as the base, then this is the height. And this distance from here will be one third of this height too. And this from here to the vertex will be two-thirds of the height too. Is this concept of geometric center being one third from base and two-thirds of the height, which we stop there and we do not complete to ourselves saying it base and height are corresponding to each other. So it is one third of the corresponding height and or two-thirds of the corresponding height, depending on whether you're taking from vertex or the base. Am I clear, class? Anybody has any question? Is it
Clear,
clear,
no, sir.
class? Okay, good. So let me show you this slide now. Here is a triangle in which area is half base into height. I have taken this as the base here, and the height I have marked as capital D. Corresponding height you can see. So it is half B into D. Caution, height being corresponding to the base chosen. So be careful. You cannot take this side as the base and still use the same height. No, the height will change, guys. Where is the geometric center of the triangle? Its intersection of its medians. Here you can see one median coming up, second median coming up, third median coming up, and this is the geometric center. What is its location? Its location is one third of the height from the base and two-thirds of the height from the vertex. Is that clear, beta? Clear, class?
Yes, sir.
Now,
Yes, sir.
about which standard axis should we remember? See, one formula can suffice passing through G, but we will add in some cases couple of more formulae so that when it comes to numericals, it makes our life easier. Okay. So one formula is definite, must, that is to be learned. But then if you learn two more formulae, when you do the numericals, you will realize that it is much, much easier. One is this one. What is this axis? XX. How do you define it? Passing through G and parallel to base B. Passing through G and parallel to base B. Okay. If it is passing through G and parallel to base B, then IXX of this triangle will be BD cubed by 36. This comes by dividing the rectangle into two, so this is not something difficult to understand also. Anyway, it's BD cubed by 36, base into cube of the corresponding height divided by 36. This formula is must. The other two formulae are strongly recommended to be learned. They will make your life easier in the numericals. Which are the two other axes? One is this one, YY. With respect to the base and height that we have chosen in this triangle, how do I describe YY? YY is coinciding with the base. It's coinciding with the base. Okay. When you take moment of inertia about IYY, it will come down to BD cubed by 12. And what is YY? YY is passing through is overlapping the base. It's running over the base. So BD cubed by 12. Another formula which will help us in questions, and when the questions come, I'll tell you why, and you'll realize how easy it becomes if these formulae are learned. This one, ZZ. What is ZZ? Passing through the vertex parallel to the base. Passing through vertex parallel to the base. IZZ is BD cube by 4. So if you learn these three formulae, life will be much, much easier. In the initial stage, what you can do is you can open this on your screen, the PDF I've shared, and first focus on application. Most of the formulae you learn as you apply. And if something is left out, you can learn it then in the evening and finish it off. Any questions on the triangle, guys? What are the slide on display? We have finished everything on this slide now.
सर
Yeah, tell me.
सर ये समझ में आया आपने बोला ना 1/3 by h and vertically 2/3 by
Yeah,
h so नहीं समझ में
correct. Where is the geometric center of this triangle? Can you tell me which point represents the geometric center?
जी
G. If I take base B, then what is the height of the triangle corresponding to base B? What is the height?
D sir D
D. Very good. Very good. So the distance of the geometric center from base will be 1/3 of D. And its
okay
distance from the vertex, opposite vertex, will be 2/3 of the D. Right? Understood?
okay sir understood
Okay. Now, if you change the base, I know then there may be doubts in your mind. Suppose you say this is the base I am taking. Then beta, the corresponding height will be whatever vertical you draw here. This will be if you take B2, height will be H2. Then the perpendicular distance of this point from here is 1/3 of H2, and perpendicular distance of this one will be 2/3 of the H2. Am I clear now? Yes or no?
sir
Is it clear?
yes sir
When you change the base, the height will change. Do you agree with me, beta? Yes or no?
yes sir I agreed
Okay. So it has to be 1/3 and 2/3 of what? The height which is corresponding to the base in question. It is corresponding to it is 1/3 and 2/3 of the height. Which height? The height corresponding to the base. Is that clear, beta, now? Can I continue
yes sir
further?
clear
Okay, fine.
okay sir thank you
Then next is the circle, guys. We all know what a circle is. It has a diameter d, it has a radius r, and where is the center of a circle? Where two mutually perpendicular or the diameters intersect. So if I draw another diameter, we know where the center would be. What is the area of a circle? Pi r square. Where is the geometric center? Intersection of diagonals. Sorry, diagonal. I said diagonal diameters. My mistake. Sorry. If I draw another diameter, we all know this is the center of the circle. Now, in this, we'll learn only one formula. Now, guys, tell me, if this is x is xx, then what do you see? One semicircle is on one side of xx, another semicircle is on the other side of xx. If I take this diameter, is the distribution of area still the same? If I take this diameter, is the distribution of area same?
Yes.
Yes or
yes
no?
sir
If I
yes sir
take this diameter, is the distribution of area still the same?
yes sir
Yes
yes
or
sir
no? So basically, the formula that we'll be learning would be moment of inertia about any of the diameters, xx, yy, or even zz, doesn't matter. The formula is pi d4 upon 64. So even if you have zz here, you say this is zz, this will also be equal to izz. It is pi d4 upon 64 or pi r4 upon 4. If you put d as 2r, it will come down to pi r4 by 4. So whichever formula you want to use in a question, you can use. So there is only one formula as far as circle is concerned. Is that clear, beta?
yes sir
Okay. So we move on to the next one. I don't think there would be any doubts here unless somebody has anything. Please speak up. Speak up. Then we go to semicircle. We have just done this circle in which this was the diameter, this was the radius, and now you see, guys, if I remove half for now, tell me what was the formula about this axis? What was the moment of inertia of the full circle about this axis? Ixx of circle, how much was it?
Pi r square by
Pi, very good. Pi d4 upon 64 or pi r4 upon 4. Correct, beta? Right? Now, if I keep the axis same, but I reduce the area to half, okay? This axis, we can do without it also, but why I'm interested in this axis is this will again make things easier. Now, it is very easy to remember it. What have you done? You have just retained the same axis, but you have just made the area half. So what will happen? The moment of inertia will become half. So for this, Ixx about semicircle will be half of this. So I know this. So it is pi d4 upon 128 or pi r4 upon 8. Is that clear, beta? Ixx will be this much. So how does it come from? It comes from making the moment of inertia of the circle half. Understood? Yes or no? Clear, beta? Okay. So one is this, and then we'll also determine the distance of the geometric center. Now tell me, okay, before I go there, okay, I'll have to keep it and
okay, sir.
then show it. Let me play it again here. Guys, tell me one more thing here. Where do you think will be the geometric center of this semicircle? Will it be on this diameter? Will it be on this diameter? Will it be on this diameter? Will be radius, sorry. Will it be in radius 1, 2, 3, 4, 5, 6? Where would it be? Where do you think it would be? Would you
It
on
can
which?
be the same.
No,
Three,
no,
sir.
on which? Three. It will be on three. It will be on three. Why? Because three is perpendicular. You have one quadrant on this side and same quadrant on the other side. So geometric center will be somewhere on this. So where will be the geometric center of a semicircle? It will be on the radius perpendicular to its diameter. It will be on a radius perpendicular to its diameter. Where does it lie? It lies somewhere closer to the diameter here. And this distance, it will come on the screen also. It is 4r by 3 pi. The distance of the GC of a diameter, the distance of the GC of a diameter, GC of a semicircle. My mistake here. I don't know what's happening. The distance of the GC of a semicircle from its diameter is 4r by 3 pi. I repeat, the GC of a semicircle from its diameter is 4r by 3 pi. Now I'll clear it and show it. You can ask any doubts as we proceed again. Okay, we had this circle. Now, area is, what will be the area? The full circle had an area of pi r square. When you make it half, it will be become pi r square by 2. The geometric center shall be on the radius perpendicular to the diameter. Why? Because you see, it will be on this line. Why? Because it divides the areas into symmetrical areas about it. So geometric center will be on that line. What is the distance of the geometric center from the diameter? It's 4r by 3 pi. You'll have to learn this formula, guys. Distance of the geometric center of a semicircle from its diameter is 4r by 3 pi. R is obviously the radius. Now we'll learn the moment of inertia formulae about two axes. One is this one. Why? Guys, it is the same axis which was for the full circle. Only thing is area is reduced to half. So Iyy will be half of what it was for the full circle. It is pi d4 by 128 or pi r4 by 8. Now this is an additional formula which has to be learned, and it is so simple that it comes from circle, so not an issue. What also has to be necessarily learned, and why are we, when I'm saying some formula are necessarily to be learned, You will understand the reason for that in a while. Another is this axis. Would anybody like to describe x-axis, guys? How can I describe x-axis with reference to the diagram? Tell me.
Axis is passing through geometric center and parallel to diameter.
Very good. X-axis is passing through G and parallel to diameter. What is the formula about this? Now, the formula about x-axis is little in something, pi upon something, r upon something. I have simplified it because when you simply put the value of pi, it comes in very simplified fraction. Why? Because the numbers keep repeating. So it is easier to remember that way. Ixx is 0.11003 r raised to power 4. So 11003, 0.11003, 0.11003, 0.11003 r raised to power 4. So Ixx will be 0.11003 r raised to power 4. So this is where we finish our semicircle, and now we'll move on to the last one. Okay. Now guys, now tell me, if I keep the axis y, and I remove another half area, so what will happen? This will be the quadrant then? Yes or no, beta? This will be the quadrant, am I right? This I'm talking about the next slide where I'm going.
Yes, sir.
Now guys, what was Iyy of the semicircle? This was for the semicircle. I am retaining the same axis yy, but at the same time, I'm making the area further half. I'm removing this half area. So what will happen? Iyy of a quadrant in this diagram will be further half of it, or 1/4 of the circle, whatever you want to say. It will be pi d4 upon 256, or pi r4 upon 16. So you have to learn the circle formula and then you can come down to it about this. That's not an issue. But before I go, okay, I'll explain on the next one. No problem. Guys, quadrant. We started with a circle. Then we removed half a circle. Then we had this line dividing into two quadrants. We had the geometric center here. And now we know about this. This one is 4r by 3 pi. And now I remove another circle. Now I'm left with quadrant. What will be the area of the quadrant? It will be 1/4 of the area of the circle, guys. What was the area of the circle? Pi r square. So this area will be pi r square by 4. Am I right? Correct, class? Now, where will be the geometric center of this semicircle? Let me just draw a circle here. Now, when I take this semicircle, which semicircle? Semicircle in red, this one. Where is the geometric center of this semicircle? The geometric center of this semicircle is here. Am I right, guys? At what distance? 4r by 3 pi. Correct? Am I right? Correct, beta? Oh, this semicircle I'm talking about, right?
Yes, sir.
Okay, now tell me guys, where do you think, now this semicircle, or it has become too much red. Let me just change it. 1 minute. Let me change the color so that discussion becomes more meaningful. Okay, I'm talking of the blue semicircle, guys, now. Blue semicircle. Blue semicircle comprises of two quadrants, quadrant 1 and quadrant 2. Guys, where do you think, if the geometric center of 1 plus 2 is here, do you agree with me that the geometric center of 1 will be somewhere on this line and geometric center of 2 will be somewhere on this line? Yes or no? That's why the combined geometric center will come at
Yes,
G.
sir.
Am I right, guys? Correct?
Yes, sir. Yes, sir.
Okay. So that means, where is the geometric center of quadrant 2? Geometric center of the quadrant 2 will be somewhere on this line. Now, I change the semicircle again. Now I take this green semicircle, beta. Green semicircle comprises of two quadrants, quadrant 2 and quadrant 3. Where is the geometric center of the green semicircle? Geometric center of the green semicircle will be here. At what distance? 4r by 3 pi. But this green semicircle comprises of quadrant 2 and 3. Where will the geometric center of 2 will lie then? Geometric center of 2 will lie on this line and geometric center of 3 will lie on this line. Yes or no? Do you agree with me, guys? Am I right?
Yes, sir. Yes, sir.
So where will be the geometric center
Yes,
of
ध्रुव कल्ला
quadrant
आपल्याला
2
आहे.
then?
That's it.
Geometric center of the quadrant 2 would be here where these two lines intersect. At what distance? It will be at a distance of 4r by 3 pi from this radius and also 4r by 3 pi from this radius. Understood, class? Yes or no?
Yes.
Okay. Anyway, little understanding will always help retentivity. Otherwise, we can always mug it up. That's not an issue. Now we have this semicircle. What is the area? Pi r square by 4. The distance of its GC will be at a distance of 4r by 3 pi from each of its radii. That means geometric center would be somewhere here. And its distance from each of its radii would be 4r by 3 pi. Now guys, tell me in this, if I take this axis, I have already explained to you, we had this full circle. I have retained the same axis y or xx, whatever it was. But what have I done? I have made the area 1/4. So what will happen? I will become 1/4 of that of a circle. What was for the circle? Circle was pi d4 upon 64. When you multiply 64 with 4, it will become 256, or pi r4 upon 4. That means it will become 16. Do you agree with me, guys? Yes or no?
Yes, sir.
Correct? Easier to remember. Now, guys, tell me, is the area distribution about this radius and this radius the same? Is the area distribution about y and z same? Yes or no? It's a quadrant, na beta? The area distribution about this axis and this axis is identical, no? Yes or no?
Yes, sir. Yes, yes.
So, I and IZZ would be equal. Doesn't matter. About both the radii, it will be same. It will be same. How much? 1/4 of a circle, or 1/2 of what it was for the semicircle, whatever way you want to learn it. But these are additional things. We will have to learn one passing through the geometric center. Definitely we'll have to learn, but that is also easy. So let me just take you through this first. Okay, now I'm sure you'll agree IZZ and IAA will be equal, and they will be 1/4 of a circle or 1/2 of a semicircle. But what I also must learn is about this axis XX or this axis YY. Guys, first tell me, is the area distribution about XX and YY same? Please see the diagram and tell me, is the area distribution about XX and YY same? Yes or no?
Yes, sir.
Guys, is the area
No.
distribution about XX and YY same?
Yes, sir.
Yes, sir.
No.
Why, beta?
Yes,
Why
sir.
no?
What is area distribution?
How is the area of the quadrant distributed about the reference axis? How is the area distributed about the reference axis? If I make two quadrants separately here, and I draw this axis through the geometric center, then what do you have? You have some area like this here and some area like this here. And if I draw this axis, don't you think this area is same as this one and this area is same as this one, guys? Is the distribution not symmetrical?
Symmetrical, sir. Symmetrical.
Yes, sir.
It is not same. Is it same about XX and YY, correct? So why I'm saying is it same? When I say it's same, that means IXX and IYY would be same. That is why I'm asking you, is the area distribution same for about XX as well as YY? Does
Yes,
everybody
sir. These
agree with the answer? Yes, now.
Yes, sir. Yes. Yes,
So
sir.
both these moment
Practically,
of,
yes,
so
sir. Yes, sir.
yeah, so the moment of inertia about both the radii will be same, whatever it is. And likewise, moment of inertia about both these axes would be same. So moment of inertia about ZZ and AA were same. Likewise, moment of inertia about XX and YY will be same. Now, guys, when I had a semicircle here, you can refer to the sheet that I have shared. What was the moment of inertia about XX? IXX of a semicircle was how much?
0.1100
11003 r raised to power
to the
4.
power of 4.
Now, I am retaining the same axis, but I am removing half the area. I have removed half the area. So what will happen? Moment of inertia will become further half. Yes or no? Correct, beta? When I'm talking of quadrant,
Correct, sir.
have you understood? No. Okay, let me do it again. No problem. No problem. Don't worry. Don't force yourself to accept. Don't
Yes,
force
sir.
yourself.
Half.
No problem. No problem. I can make out from the response whether people have understood it or not. Don't worry. Okay. On the previous slide, we had a semicircle, guys, and here was the geometric center of the semicircle, and we had drawn the axis XX and IXX we had written there as 0.11003 r raised to power 4. Does everybody agree this for semicircle?
Yes, sir. Yes, sir.
Okay.
Yes.
Now, what are we saying is I'm taking a quadrant. Which one? I am taking, say, this quadrant. Now, where is the geometric center of the quadrant? We just said it is here. Now, hey, 1 second here. I had the door open. There is a cat which came in. Anyway, it's gone. Okay. Now, guys, sorry. Now, you see, guys, in this case, this is the geometric center of the quadrant. Now, is the axis XX remaining same? Yes or no? As semicircle? This axis through the green G, the blue G, is it remaining same as for the semicircle? Yes or no? Correct, beta?
Yes, sir. Yes, sir.
Yes, sir.
And what are we doing? We are retaining the same axis, but we are removing half the area from semicircle. Correct, beta? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
So what will happen? For quadrant, IXX will be nothing but half of what it was for the semicircle. Understood?
Yes.
Yes, sir.
Understood? So you don't have to make it another fraction. Just remember it like make it half. Calculator will do it the job. Don't have to remember 0.11003 on one side and don't start dividing it and then make another fraction to learn. Don't remember. Just divide by 2, na? Formula, just leave it there.
Right, sir.
So you don't have to unnecessarily make it another fraction. You can just use it the way I have used it here. You can see it here on the slide now. And if you have any questions on it, please let me know because this is the last of the slide as far as regular geometric shapes is concerned. IXX and IYY would be equal. I had explained to you a while back. And they would both be equal to 0.11003 by 2 r raised to power 4. So there is no new thing to be remembered. This is also half of the semicircle. This is also half of the semicircle. Correct, beta? So quadrant is nothing new, no new formula as it is. So if you can link it to the previous formula, then the number of formulae you'll have to memorize would reduce. That will come down. Clear, beta?
Yes, sir.
Okay.
Clear.
Yes.
Okay. Yeah. Now, last thing before we start with the questions. theorem of parallel axis. Now, guys, this is all handwritten. If you want at the end of it, you can take a screenshot, or if you want to take down anything, please take down. Guys, this is again, we had done two theorems in school, parallel axis and perpendicular axis. Perpendicular axis we are not going to use here. What is theorem of parallel axis? If you have any area, I am drawing rectangle only for the sake of convenience, that's all. It can be any shape, guys, regular, irregular, curvilinear, non-curvilinear, it can be anything. Let us say we have this area A. I'm not commenting on the shape. And we have its geometric center somewhere. Okay. Now, if I want to have the moment of inertia about any axis like this, it can be outside the area, it can be here also like this. It can be anywhere. It can be coinciding with the line here. So it doesn't have to be totally out always, okay? So let me just redraw it. We have an area. We have an area A. Shape of the area is immaterial. I have a geometric center of it, and I want moment of inertia about, let us say, this axis. Now, this could have also been like this, guys. Doesn't matter. So I want about this axis. Then what do we do if we have to apply theorem of parallel axis? Is we draw an axis through the centroid of the area parallel to ZZ. So we draw an axis parallel to ZZ through the geometric center. Let me call it as YY. So what is YY? YY is an axis drawn through G parallel to ZZ, the axis about which you need moment of inertia. Now, these two axes being parallel, you find the perpendicular distance between them. Let us say the distance is D. Then, as per theorem of parallel axis, IZZ will be equal to IYY plus area into square of perpendicular distance between them. This is the expression for theorem of parallel axis. Now somebody may say, sir, aapne to, you made a rectangle. No, I can make it like this also. This is A, this is the geometric center. I want about ZZ. Then I draw a parallel axis through this, maybe YY. This is D. The expression still remains the same. Understood, class? Yes or no? Clear, beta?
Yes, sir.
Yes, sir.
Now, sometimes if it comes in theory, describe the theorem of parallel axis. You describe this expression in words. What will you write? As per theorem of parallel axis. I'm writing here so that you can take a screenshot. As per theorem of parallel axis, moment of inertia about any axis, which is the any axis in this diagram, ZZ, is equal to, I'm writing, just giving it words to this expression, is equal to sum of MOI about a parallel axis to the geometric center of the area, which is that axis in our expression, in our diagram, YY, and the product of area with square of distance between the parallel axes. What have I done? I've just given words to this expression. Correct, beta? Nothing else? Yes or no?
Yes.
Am I right?
Yes, sir.
I've just given it words. Correct, beta? Am I right?
Yes, sir.
Yes, sir.
Right.
So if it comes in theory, you can write this and then draw one diagram and write this expression explaining what you are trying to say. So this screen becomes the answer to the theory question in case somebody in theory happens to ask you, describe theorem of parallel axis. But we'll be very often using it in our numericals. Now, before I close this slide, please pay attention. Look at the expression. What is I? Would you like to speak? What is Y rather? What is Y? Describe axis Y
So passing to the geometric center.
and parallel to
Parallel
the
to the
given
Parallel to
axis.
the
Given axis,
sides.
correct? Correct. So guys, see, if you have a series of axes, then is the, let us say this is one axis, this is two axis, this is third axis, this is through the geometric center. Out of all these axes, moment of inertia will be least about which one? Will it be least about ZZ, 2 or 3? They are
Y.
all parallel to each other.
Bye bye.
Y. Remember this. Remember this expression here. If you want moment of inertia about ZZ, then it is plus AD square. But in questions, if I want moment of inertia about the axis passing through the parallel, through the geometric center, then it will become I. This is not part of explanation now. I'm just drawing your attention here. This will be IZZ minus AD square. Please remember this. Is that clear, beta?
Yes, sir.
Am I
Yes, sir.
right?
Yes, sir.
Okay. So anyway, that's, you need to take note of it. Now, I also told you that all the 5 shapes that we did extra formulae, but every shape there was definitely a formula which was about an axis passing through the geometric center, be it rectangle, triangle, circle, semicircle, quadrant. Correct, Peter? Correct?
Correct.
Why did we learn one formula about, in every case, an axis passing through the geometric center? Because if I have to deploy the theorem of parallel axis, then one of the axes has to pass through the geometric center. You cannot directly apply theorem of parallel axis between this axis 1 and axis 2. Am I clear, beta? Just because 1 and 2 are parallel does not mean you can apply theorem of parallel axis. For theorem of parallel axis, the two axes must be parallel and one of them must pass through the geometric center. Am I clear, class?
Right, sir.
Yes, sir.
Yes.
Yes, sir.
For theorem of parallel axis to be applicable, there are 2 criteria to be fulfilled. Number 1, both axes must be parallel to each other. If they are not parallel, then it doesn't apply. 2, one of the 2 axes must pass through the geometric center. If none of them pass through the geometric center, you cannot apply theorem of parallel axis between them. Am I clear?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay, please don't make that mistake because the axes are parallel, you apply parallel axis. No, in theorem of parallel axis, if you read what I have written, it's sum of moment of inertia about a parallel axis through the geometric center or the centroid. So one axis has to pass through the centroid, otherwise theorem of parallel axis will not be applicable. Clear, class?
Yes, sir.
Okay.
Yes, sir.
With this, I come to end of this presentation. If you want to take screenshot or something, please do that. I'm closing it then. Okay. And then it will be cleared off. Now it's time for us to go on to the numericals. Now, what I'll do is I'll give you 5 minutes break. It's 10:39, 10:45 sharp. We'll start with first application of moment of inertia, center of pressure using regular geometric shapes. Okay. 10:45, guys. Okay.
Okay, sir.
Okay. Thank you.
Okay, take a break. No problem. Okay, guys, let's be back, please. Let's be back to the class. It's 10:45. Okay, guys, good to continue.
Yes, sir.
Okay,
Yes, sir.
now we go on to the first application of moment of inertia, and that is center of pressure. Guys, what is weight? Weight is a force. And like the ship's weight is not a singular weight. It's the weight of the hull, weight of the cargo, weight of the people, weight of equipment, weight of stores, put here and there all over the ship. But when I take ship as one object, as one piece, then if you add all the weights, that gives you the total displacement of the vessel. And if I take ship as one object, this entire weight can be assumed to be acting through which point, beta? This total weight of the ship can be assumed to be acting through which point?
Center of gravity.
Center of gravity, correct? Yes or no? Correct?
Correct.
Yeah. What is center of gravity? It is the center of force. Which center of force? Which force? Force of the weight. If you have buoyancy, which is contributed by the underwater volume of the ship from one end to the other end, from one side to the other side, from keel to the water line. But if I treat buoyancy as singular force, then it can be assumed to be acting through its center called as center of buoyancy. Am I right, guys? Yes or no? Correct?
Yes,
Yes.
sir.
We have all studied about thrust in the pre-sea. What is thrust? Thrust is the force experienced on an immersed part by the pressure of the liquid, by the liquid force on a area. Correct? Do you remember, guys, thrust? Yes or no? In ship stability, how were you calculating thrust? You were calculating thrust in multiplying the pressure at the GC of the body, pressure at the GC of the area multiplied by area. Do you remember this? At the what were the units of thrust? Tons. Correct, Vita?
Yes, sir.
How was thrust defined? It was defined by as a force exerted by the liquid on an area, like a bulkhead or whatever, right? So thrust, it was not only at one point, it was acting all over the area. Somewhere it was more pressure, somewhere less pressure. The force over the entire area was the thrust. Like weight was a force, buoyancy was a force, thrust is also a force. If weight had a center called center of gravity, buoyancy had a center called as center of buoyancy, then this thrust should have also a center through which the entire thrust can be assumed to be acting through. Am I right, guys? Correct? Then there should be a point which should act as center of force for thrust. Am I right, guys? Like
Yes.
center of gravity and center of buoyancy.
Yeah.
This
Yes, sir.
point, this point through which entire thrust can be assumed to be acting through is called as center of pressure. So what is center of pressure? It is the point through which the thrust on a surface can be assumed to be acting through. Guys, I'm revising pressure and thrust again because in questions I don't want to take chances that later on we come back again struggling with it. Pressure at any point is the force per unit area, and its SI units are newtons per meter square. But in ship stability, because ships operate on the surface of the earth where G is practically same, G is kept aside for the sake of convenience. G is not forgotten or missed out. It is intentionally kept aside. As regards ship stability, we limit our scope to pressure exerted by column of a liquid at any point below the surface. The pressure due to a column of a liquid at any point below its surface is the depth of the point multiplied by density multiplied by acceleration of gravity. This is the correct physics expression for pressure. In ship stability calculations, as we do, they refer to ship floating at the surface of the earth, where G is practically constant. It is intentionally left out of calculations for the sake of convenience. So in ship stability, when we say what is pressure, We basically say it is the depth of the point below the liquid surface multiplied by the density, and then we say pressure is in tons per meter square. Am I right, guys? This is what you have learned in pre-C, correct? Am I right? Correct, class?
Right, sir.
So, basis the above formula, the unit of pressure will be tons per meter square. So, if you have to calculate pressure at any point, then you have to find the depth of that point below the liquid surface multiplied by the density, and you'll get the pressure as far as ship stability is concerned. And units will be ton per meter square. What is thrust? Thrust is the pressure exerted on a surface. As regards the ship stability, we limit our scope to thrust, that is force exerted by liquid on an immersed surface. Thrust on an immersed surface is obtained by multiplying the pressure at the GC of the surface, GC of the area, and multiplied by the area, immersed area. So GC of which area? Immersed area. Multiplied by which area? Immersed area. And we just said what is the pressure? Pressure will be the depth of the GC of the immersed area. From where? From the liquid level multiplied by the density of the liquid. This becomes the pressure, guys. This is the pressure. Pressure multiplied by area gives you thrust. The unit of thrust is tons. This also you have done in pre-C, guys. Are you able to connect now? Anybody
Yes,
has
sir.
any questions? Okay. Then what is center of pressure? Thrust is the force exerted by liquid on an immersed surface. If thrust exerted on a surface is to be considered as one force, it can be assumed as one force acting through, assumed, not actually, assumed acting through the center of that force called center of pressure. I have already tried connecting it to the other centers of forces like center of gravity and center of buoyancy. Now, guys, as far as the formula for center of pressure is concerned, its derivation is not part of our syllabus, but if you are interested, it is there in Derrick's stability booklet book. Okay, anytime later on you want to see, I can share the source where the derivation can be reached. That is Derrick's stability book. What is the formula for COP? The formula for COP is this. This is actually in subscript DLL, like this. Guys, now let's understand this formula once for all. COP stands for center of pressure. This formula will give you its distance always from liquid level, nowhere else. The formula will give you COP only from liquid level. If you want it from somewhere else, you cannot change the formula. First, you'll have to calculate from liquid level and then adjust your answer to meet the requirements of the question. Formula will remain COPLL. What is LL? LL is the reference axis. This is equal to ILL. Now, guys, you see, I have put LL, that is the reference axis in the subscript. What is I? Moment of inertia. When I said moment of inertia, I said ask yourself two questions. Moment of inertia of which area, which axis? Axis is evident, it's written LL there. Which area? It is the immersed area. So ILL is the moment of inertia of the immersed area about liquid level. What is A in the denominator? Immersed area. What is DLL? Distance of the GC of the immersed area from the liquid level. Distance of the GC of the immersed area from the liquid level. Guys, this formula will not change, come what may. This formula will remain whatever it is. COPLL is the distance of the COP from liquid level. ILL is the moment of inertia of the immersed area about liquid level. A is the immersed area. And DLL is the distance of the GC of the immersed area from liquid level. Guys, do you have any questions to clarify? Because when we do questions, what will we have to do? We'll have to draw the diagram, identify the immersed area, mark the liquid level, and then get ILL, A, and DLL, put them in the formula, and we'll get COPLL. Any questions, guys, on this? Please let me know. The formula will not change. Please bear it in mind. Formula will always give you distance of the COP from liquid level only. It will not give you from any other reference axis. You cannot say, can I take moment of inertia about base and make it COP base? No. Answer is no. You have to get it about the liquid level and then make the adjustments. Am I clear, class?
Yes, sir.
Clear, beta?
Yes, sir.
Guys, I have shared these questions with you. Now we'll do some questions, and that will now see one or two questions. I'll keep talking to you as I'm doing them so that it makes better sense to you. And then I would like to hand over the lead to you so that now, guys, read this question. Transverse bulkhead, all these questions have been shared with you already. They are with you guys. Transverse bulkhead of a tank is 10-meter high, wide and 8 meters high. Find the thrust on the bulkhead. We already know how to calculate thrust and the distance of its COP from the base. He wants the distance of the COP from base. Sometimes that's also referred to as KP, keel to COP. If tank contains seawater of RD 1.010 to a head of 3 meters. Guys, the first thing you'll do in these questions is make a diagram. Okay. How will you make the diagram? It's a bulkhead. You all know how to make a bulkhead. It's a rectangular bulkhead. So here is the bulkhead. It is 10-meter wide and 8 meters high. Guys, it has a head of 3 meters. What does it mean? Anybody in the class wants to say? I know many of you would be knowing it. What does it mean when you say the head
The
of 3 meters?
sounding pipe.
Sounding pipe is 3 meters above
No,
the
not
tank.
sounding, not the sounding pipe, beta, water level. What sounding is 11 meters then, right? That means sounding pipe can have 15 meters of height, but the liquid is up to 3 meters above the top of the tank. That means the liquid level is like this, and this is the liquid level, and this is 3 meters. Have you understood the meaning of head? Yes or no? Clear, beta?
Yes, sir.
That means water is in the sounding pipe, air pipe, whichever ventilators there you have out there in the compartment. The water is filled into that. Why it's called head? Because it's above the body of the tank. Your head is above your main body, above your shoulders. Your main body ends at shoulders, and then you have the head. So it's a head of 3 meters. So obviously, what is the sounding on the tank, guys? 11 meters. Does everybody agree?
Yes, sir.
Then you will identify the immersed area of the bulkhead. How much of the bulkhead is immersed? Is it fully immersed or partly immersed?
Is a fully immersed.
Fully
Partly.
immersed. Why it's partly immersed? Tell me, beta.
नहीं ठीक है सर फुली वो ऊपर हेड पे आ गया उनके
Okay. ठीक है. Okay. Now, so my area of interest will be the full area. Why? Because it is fully immersed. To get the thrust, I need the geometric center. We did a while back. Where is the geometric center of a rectangle? It's intersection of the diagonals. Correct? Guys, can you tell me what will be DLL, distance of the geometric center from liquid level? Look at the diagram and tell me the value.
7 meters.
Very
7
good.
meters.
Speak with confidence, no? Why were you so apprehensive?
7 meters.
This is the immersed area, guys. This is an axis here. We'll come to it later. This is DLL and this is 7 meters. I'm now sure you can get the thrust. Thrust will be pressure at G. Pressure at G will be 7 meters into 1.0010 into area. Immersed area is 10 into 8. See, DLL is 7 meters. Now we are good to get the thrust. Can you please calculate the thrust and give me the answer in tons, guys? Calculate the thrust and give me the answer in tons.
565.6.
Guys, keep your calculator handy. I can keep showing you and the syllabus will get over in no time. And that is not the intention. Okay. And you should carry home for the after the class minimum work, whatever is necessary. Not that everything you do again at home. You would have other subjects also to cater to. Everybody is good with thrust, guys? The first part of the question? Yes or no?
Yes, sir.
Second is he wants the distance of the COP from the base. Base is this is the base of the bulkhead, guys. But my formula will never be from the base. Can you, in your mind, can you repeat or revise the formula once again? COPLL is equal to ILL upon A into DLL. How much is the immersed area? You already know 80 square meters. What is DLL? You already know 7 meters. So what is left now? We have ILL to deal with. Am I right, guys? Correct?
Correct.
Yep. Now, guys, we have to find what is ILL? Moment of inertia of the immersed area. In the diagram, the light blue shaded area is the immersed area. I have to get the moment of inertia of this area about LL. Guys, go back to that PDF I've shared. And answer the question, is LL a standard axis? When I say standard axis, what does it mean? I mean about which we have already done a formula there. Is LL a standard axis for the immersed area?
No, sir.
No, sir.
Everybody agrees no? Answer is no, but everybody agrees yes or no? So if it's not a standard axis, if not a standard axis, we can explore the possibility of using theorem of parallel axis. What will I have to do? I'll have to draw a parallel axis through G. And I have already drawn that as small gg. What is gg? Is it passing through the geometric center and parallel to LL, guys? Yes or no?
Yes, sir.
Yes, sir.
So now if I have to apply theorem of parallel axis to get ILL, what will the numerator become? ILL is equal to, please speak up, ILL will be equal to with reference to the diagram.
10 into 8 cube.
Array, with reference to diagram,
IgG.
what? IgG
IgG plus A into D
D
square.
A into DLL square, correct?
Correct, sir.
Am I right? Will it become like this, guys? Yes or no?
Right, sir.
Anybody who's not aligned, if you have a problem, please sort it out at the beginning itself so that your time does not get wasted, guys. Otherwise, you'll keep looking and keep struggling. Is the application of theorem of parallel axis correct, guys, on the screen? Yes or no?
Yes, sir. Correct.
Now, what is IgG now? Tell me. Tell me the values, what to multiply, not the value, calculated value, what to multiply with what and how do I get IgG? Look at the diagram. All values are already posted.
Then L into
10
B cube
into 8
upon
cube by
No,
10
tell me tell me the values, what to
10
multiply. Now
into
I
8 to
don't
the power 3 upon 12.
10 into 8 cube by 12. Correct, guys? Yes
yes,
or
sir.
no? Plus area is 80 square meters and DLL is 7 square. divided by area is 80 and DLL is 7. Can you please, firstly, is everybody convinced with this? Yes or no? अगर कोई doubt, please, if you have any doubts, don't live with your doubts. There's no point in attending the classes if you have to go with doubts from the class, guys. Please. All good. Calculate COPLL. How much do you get? Use your calculator. Using effectively calculator also is important for exams, guys.
7.7619.
Okay. Round off to third decimal place, 7.762 beta. Okay.
Yes.
Does the question want from liquid level? Look at the question, guys.
From base.
Question wants from base.
From
So
base.
look at the diagram. How can I get now from base? I have got the distance from liquid level.
3 meters, sir?
So from sounding, I can subtract it. Yes or no?
Yes, sir.
minus 11.
Guys, this is, COP base will be equal to how much? You see, this is the sounding, guys. This is the sounding of the water, right?
11 minus 7.762.
Yes, correct. You see, it has come on the diagram. I didn't know that it's on the diagram also. Sounding 11 meters. And the answer is 3.238 meters. Anybody who's got any doubts, you can clarify with me, beta. The purpose of this question was to make you apply the thrust concept, thrust formula, and also learn to use the theorem of parallel axis and get COP. So that was the objective of this question. I hope everybody has. So now when you have the theorem of parallel axis required again, you have to calculate the thrust. You should not be struggling with these things. Am I right, guys? Anything new, we can discuss. But whatever we have covered here, that should not be bothering you. Can I expect that, guys?
Yes,
Shall we go to the next question then?
Yes, sir.
Sir, I have one doubt.
Yeah, tell me.
Sir, in this COP, we have found out COPLL.
Yes.
So in all the questions where we will find out COP, this is the standard formula, sir. Is it correct?
That's what I said a while back. That
Yes,
you can't
sir.
change.
Okay.
I think I said
Well,
4 times you can't change the formula, right?
Yes, I had some problem with my network, so that's why just confirming.
Okay. Is it clear now, Keshav?
Yes, sir. Yes, sir. It is clear.
Okay. COP formula will remain COPLL only. It will not change. You can't write COP base is equal to some formula, right, guys? Correct? Okay. Clear?
Okay, sir.
Okay, fine. Let's go to the next question. Guys, can you make, this is from MMD, August 2019. Can you please make the diagram as per the question? Now you take the lead, I'll show you. I have digitized, guys. My intention is not to run away with run through the class and just keep showing you. Please read the question, make the diagram, load the values from the question, identify the liquid level, and then stop.
Excuse me, sir.
Yeah, tell me.
Sir, sorry. I was trying to ask the question, but I realize now that my mic was muted. Sir, I understand that the volume of, like in last question, we had a 3 meter head, right? I understand that this area which of water which we have in the pipe is very less. But are we not considering that? Because that will also act, right?
My dear friend, we are
Yes, sir.
finding COP of the bulkhead. Okay.
Okay, sir.
In a ship, the tank, in a 3D diagram, the tank is like this. Okay. The sounding
Okay,
pipe
sir.
and air pipes are not part of the bulkhead. They are like this. Correct, beta?
Correct, sir.
Are they part of the bulkhead?
No.
It is confusing you because it's a 2D diagram, right?
Okay, sir. I
In
understand.
a 3D, if you have ever been in a tank, The sounding pipe is free of the bulkhead. It's not part of the bulkhead, correct?
Correct, sir. Correct. Correct.
Okay. Okay. Continue. Do the next one. It's a MMD question. The more, if you can make a good diagram, appropriate diagram, at least one step is taken correctly here. Don't worry. Guys, this is the diagram I have made. Is it what you have made also? Tell me.
Yes, sir.
Yes.
Anybody who needs support in the diagram up to this point, let me know. The liquid level is at a 8 meters distance from the bottom because sounding is 8 meters. Correct, Peter?
Right, sir.
Now, guys, first find the thrust on the bulkhead and the position of the COP with reference to the bottom. This time, again, he wants from, sometimes they also write KP, keel to center of pressure. So that means the same. Don't get confused. Now, guys, to get thrust and to get COP, you need this area. The blue area is the immersed area. I have identified the immersed area, guys. You should shade that. Please shade the immersed area lightly with your pencil or pen. These things will help you in minimizing the mistakes. Now, we have to calculate this area for which I need X. Am I right, guys? Yes or no?
Yes.
I need the value of X to get the immersed area. Correct, guys? If I don't have the value of X, can I get the immersed area?
Negative.
No. Now, how can we get? We'll use similar triangles. The blue triangle and the bigger triangle are similar. The ratio of their corresponding sides and corresponding heights is always equal. Okay? If anybody does not understand what I'm saying, please ask me, clarify if you have any issues. By theorem of parallel axis, side X is corresponding to side 9 meters of the side X of the small triangle is corresponding to side 9 meters of the bigger triangle. Height 8 meters of this triangle corresponds to height 12 meters of the bigger triangle. So the ratio of the two will be same. So by similar triangles, X by 9 will be equal to 8 by 12. And if anybody has not understood this, please clarify. Baad mein mat kehna ki this is what I missed out. Please. I know most of you would be knowing it, and only there may be one or two who may be struggling, but you should not just sit quietly. And this will give us the value of X. If anybody has any doubts, let me know. Do we get X as 6 meters, guys?
Right.
Yes, sir.
Yes.
Put it on the diagram and calculate the area, immersed area. Can you calculate the immersed area and give me the value, guys?
24 meters.
Units भी बोला करो बेटा, खाली 24 मीटर मत रुको, 24 मीटर square.
24 meters per.
Very good. Half base into height. 6 meters is the base and corresponding height is 8 meters. Can you calculate the thrust now, guys? Find the geometric center, DLL. What will be DLL, guys, in this case? Mark the geometric center. What will be DLL? Go to the properties of triangle we covered, guys.
1/3 of the.
One third of from the base.
No, one third.
4 meters.
Tell me DLL.
1/3 of the height. 1/3 of the height.
4
It will be
meters.
8 by 3, right? Leave it 8 by 3. Don't waste time in
Yes,
dividing it. Here will be the geometric center, and this will be the axis through the geometric center, and this is DLL, which is 8 by 3 meters. Correct, class? Yes or no? 1/3 of the height from base. Base is 6 meters, right? And corresponding height is 8 meters. So it's 1/3 of the height from base. Correct, class?
Correct, sir. Yes, sir.
Everybody to get the thrust now, because question 1 part is thrust. Please calculate the thrust now. Units of thrust would be tons.
60.
Guys. Sorry?
65.6 tons.
Okay, sounds familiar value, beta. Seems to be correct. Seems to be correct, but we'll check in a while. Can somebody validate what he's saying? Is that correct or not?
Yes, sir.
65.6.
Okay, very good.
65.6.
Okay, very good. Anybody who needs help in calculating thrust, please let me know now, because once I show, then you will feel you knew it here. Guys, anybody who needs help in thrust, don't hesitate.
Sir, please repeat.
Yeah, what do you want me to repeat, beta? Tell me.
The thrust, how to?
Okay, previous question, how did we calculate thrust?
So thrust up DLL into density into area.
Pressure at the GC into area, correct?
Correct, sir,
Yes or
correct.
no? Durgesh, was that Durgesh or Samir who had the doubt?
Please, Samir.
Yeah, Samir. So it was. So what? So tell me now, what will be the pressure at G in this diagram? How do I get the pressure at G? How do you find pressure
8
at a
by
point below? Anji?
sorry, sir.
Arey, go back now, beta. We have just done a question, Samir. How do I get pressure at G in this case? How did you get pressure in the last question?
Last question, pressures are DLL into density into area.
That was thrust. That was thrust, beta. If you remove area, whatever was remaining was the pressure at the GC, right?
Yes, sir.
Okay. Chalo, you got thrust that way. Now, what will be the thrust now then? The same way if you go. What is DLL? How much is DLL, Samir?
Sir, DLL 8 by 3
8 by
into
3 into what is the density of the question? In the question,
1.012.
in the question, where is it written 1.012 in this question?
In this question, sir, no density, so seawater
Are you sure?
1.025.
Okay.
1.025, sir.
And what is the area? Immersed area.
What area? 24.
So you can't get thrust, beta. Can you get now?
Yes, sir, what now?
Tell me the answer quickly. जल्दी बताओ. Time calculator multiply your फटाफट answer बताओ. Good, you are asking. Don't worry. Tell me the answer.
65.6, sir.
Units. Units of thrust.
Ton.
Very good. Okay. DLL, guys, will be 8 by 3 meters. Thrust will be pressure at GC into area. Pressure at GC, Samir, this is the pressure at GC, beta. This is the pressure. Okay. Okay. Is that clear,
Okay.
Samir? Into area. Beta, if you're not talking to me, please mute yourself. You have all these values, you put them here, and you get 65.6 tons. That is one part of the question, right, guys? Now, guys, write down the COPLL formula. Write down the COPLL formula. This is the formula correct, guys? Yes or no? It will not give, formula will not change. You can't
Yes,
write
sir.
it
Yes,
from
sir.
base, it will, right. Now, guys, look at the diagram and go to the triangle moment of inertia formulae. Is liquid level a standard axis about which we have learned any formula? And now you'll understand how
No,
it,
sir.
are you sure?
Yes, sir.
Go
We
back.
This is
understand.
no standard formula.
Is it a standard formula? Which one?
No, sir. No.
Hmm.
It is, sir. It is BDQ by
It is
QC.
standard axis.
Sir,
Yes.
DG is the standard axis.
Okay, let me address yes. Yes, how many formulae have been done for triangle?
Sir, we have done 3 formulas for triangle, but
Okay, can you now define the axis? First formula is about which? Don't say XX. Define the first formula is about
sir,
which axis?
DG. IGG.
G. Second formula is about which axis?
ILL.
अरे यार,
The base and base.
उसमें LL कहाँ था यार? When we did three formula.
That one is YY.
YY was what? I don't remember YY. Which was YY?
The base
Beta?
one. The base,
Base, sir,
the
base.
base.
So is liquid level not the base?
Yes, sir, is the base, sir.
So we can avoid using the theorem of parallel axis. Nah?
Yeah, yes,
If
sir.
this will save you time, correct?
Yes, sir. Yes, sir.
Samir, are you getting?
Yes, sir.
Okay. So if you want to use theorem of parallel axis, you can use it. I have nothing against you. You'll get the same answer. I have used theorem of parallel axis. You see, and you do it straight, and you'll get the same answer. If I have to use theorem of parallel axis, it will be IgG plus A into DLL square upon this. IgG for me will be BD cube by 36. You see, I have done it the longer way and comes 4 meters. And what can you do as a shorter way? You can just do
सर
it like
उसको
this.
बेस भी तो बना सकते हैं ना
इसको तो बता तो रहा हूँ, that is the shorter way. Which is the shorter way then? That's what we are saying, na? Akshay, you
ठीक
don't listen to me fully, na?
ठीक सर ठीक
If you don't want to do this way, which is longer way definitely, and you have learned the 3 formulae, then COPLL will be equal to ILL will be base 6 D cube 8 cube upon 12 divided by area 24 TLL 8 by 3, and this will again give you the same answer, guys. Correct? And you save the hassles of going through the theorem of parallel axis. Correct? Am I
Yes,
clear,
sir.
class?
करेक्ट सर करेक्ट
So whichever way you want to do it, if you use the BD cube by 12 formula, you will not have to apply theorem of parallel axis. If you want to use BD cube by 36 formula, you will have to apply the theorem of parallel axis, right? Anybody who has a doubt in this question, guys? Samir, have you used theorem of parallel axis, or are you doing without theorem of parallel axis? How are you doing it, Peter?
Sir, use parallel axis theorem.
But why you want to use it? You learn the other 2 formulae, no?
Yes, sir.
There is one formula there where it is the axis is coinciding with the base, correct?
Hello.
Yes, sir, correct.
And what is the formula for that axis? BD
BD
cube by 12, correct?
Yes, sir, correct.
And is liquid level
Americano.
coinciding with the base of the one of the sides of the triangle, blue triangle? Yes.
Dinare kidduwa mana phone message awala.
Yes, sir.
Awam kidduwa.
So can we apply directly? Then you don't have to use theorem of parallel axis, na beta?
Formal peru ne
Okay.
Okay.
Acha.
Samir, you have to keep asking questions, beta. Don't go into hiding, okay? If you really want
Okay,
to
sir, sure.
benefit, keep asking. Don't worry, guys. Anybody has any doubts on question number 2? It's a MMD question, August 2. Bolo, tell me.
We got this COP as 4 meter, but in the question it was asked like.
No. So you complete. No. You complete. Nah, my thing is coming. COP base is equal to 8 minus 4 equal to 4 meters. The last line is coming up here, beta.
Okay, sorry, sir.
It's coming up here. You'll give COP base.
Yes, sir. Okay, sir. Thank you.
Okay. So through these 2 questions, one of them being a MMD exam question, we have learnt, and here similar triangles, I hope everybody is clear with. If a similar triangle again comes in the questions, you should not be struggling. Then you should be by yourself getting the values, guys.
Sir, why we are finding this COP everywhere? What is the use of this COP?
COP uses, suppose your one of the holes is bilged and filled with water, right? Okay.
Yes, sir. Yes, sir.
So your force will come on the bulkhead, right?
Yes,
and suppose if you have the fear of the bulkhead collapsing, then from the other side you may like to do some shoring, some support to the bulkhead, correct?
Yes, sir.
So where should your shoring actually be more concentrated? It should be more concentrated closer to the center of pressure, around that area. Okay? Right, beta?
Okay, sir.
Otherwise, the answer to this is we have to pass phase 2. Okay. Chalo. We go to the next one then, guys. Now you guys have to take lead, guys. The more you do now. Can you make a diagram to this? Whatever you think. Don't think of how you'll solve it. First, can you translate text into diagram? Please read the question and do it. Just make the diagram, load the values. Don't worry about it. Mark the liquid level. Only that much you need to do. Have you made the diagram, guys? Should I show it?
Yes, sir.
Yes, sir.
It's a rectangle atop a triangle. That means rectangle on top of a triangle. So somebody may say width of the triangle is not given, guys. We have all worked on the ships. You know what will be the width of the triangle. If the rectangle is 10 meters by 8 meters, then obviously the base of the triangle will be 10 meters. And this is the diagram we are talking about. Yes or no, beta? Everybody made like this?
Yes, sir.
Yes, sir.
Where will be the liquid level? Have you marked the liquid level? Read the question and mark the liquid level. Where will it be, guys? Where will be the liquid level?
4 meter from the
Center of the
base of
rectangle.
the triangle.
Midway in the rectangle, right? Like this, correct, guys?
That's correct.
Correct. And this will be the immersed area. Have I shaded the immersed area correctly?
Yes.
Yes.
Okay. Now, guys, to get the thrust. Okay. Now, guys, we can divide this into two areas. 1 and 2, area of a triangle or rectangle, 1, 2, whatever you want to call it. Doesn't matter. I have called this as area 1 and area 2. Can you, and I'm only talking of the immersed area. Can you please calculate area 1, please, and give me the value? Immersed area 1.
40 meters.
40. Okay. Okay. A1 is 40.
No, sir. A2 is 40. A1.
Okay. 15, right?
That's
okay, guys. Okay, guys. What is the distance of the geometric center of A1? It has come as G1 in the diagram.
from
What is
LL.
D?
From
What
LL.
is D1LL, guys? What is D1LL? Tell me. No, give me the full answer. What is D1LL?
1 meter.
5
D1LL.
5 meters.
D1.
LL. This one. How much is it?
5.
Yeah, so you need from liquid level. What will you do with the base here? Correct? Yes or no?
Correct.
So D1LL is 5 meters. Everybody agrees with me?
Yes, sir.
Please mark. Okay, so D1LL is 5 meters. What is area 2? Somebody has already said 40 square meters, so I'll not waste time on that. Please mark G2, the geometric center of area 2, and give me D2LL. How much is D2LL?
2 meters.
2 meters is one answer from the class. D2LL class, mark G2, 2 meters. Very good. 2 meters, correct. Now, D2LL is 2 meters. Okay. Guys, what is the total immersed area? 55 square meters, correct?
Yes, sir. 55.
Guys, in phase 1, you have learned how to find the geometric center of a combination. Can you find DLL now? DLL. That means distance of geometric center of the combined full immersed area, that is rectangle plus triangle, from the liquid level. How were you doing in phase one, guys? A1 into D1LL plus A2
Sir,
into D2LL upon A1 plus A2. Am I right?
Yes, sir.
sir, I have a doubt.
Yes, sir.
Tell me.
Sir, D1LL 5 है ना?
How?
The
कैसे?
geometric center of the triangle is the depth 3 meter है तो half 1.5 plus
Half
4
होता है.
meters.
Triangle for triangle it is half.
No, sir.
What is the distance of geometric center from base? How much is it? See, you must have remained entangled with this doubt for a long time and you would have missed the remaining discussion. How is it? Is the geometric center of a triangle half of the height? Samir? Samir, what is the distance of the geometric center of a triangle from base?
Sir, 1 by 3 into h, sir. H.
So why are you saying half? See, problem ये है तुम वहां पे अटके रहोगे और तुम्हारा आगे का डिस्कशन सारा मिस हो गया. Can you guys calculate DLL then? You have A1, you have a D1LL, you have A2, you have D2LL.
2.818.
2.818.
2.818.
Very good. Calculate. DLL will be equal to 15 A1 into 5 D1LL plus 40 into 2 upon 55, 2.818 meters. Right, guys?
Correct.
Samir, this step is clear to you?
Yes, sir. Clear.
Pakka?
हाँ स्नेहल
A1 into D1LL plus A2 into
पहुंची
D2LL
गयो
divided by A1 plus A2, right? Moments, phase
मैं
1.
आओ અડધો
When did you
કલાક
do
માં
your
આવું
phase 1, Samir, beta? Just for the sake of
મેં એટલે
better
લેક્ચરમાં છે
understanding.
પતવાનો આવે
Last one.
હા
Have you cleared Naval Arc 1 or is that is also pending?
अभी last time did paper अभी. Next.
Abhi diya tha, then you would be okay with it. Then you would have done Simpson's rule system. Okay, fine. Then I'm okay. Okay.
sir.
Guys, can you calculate the thrust now? Please calculate the thrust. Samir, thrust बताओ मेरे को कितने टन से?
Okay, sir.
Get me the thrust.
Sir, 104.829.
Okay, we'll see. Is he right, guys?
Those are 144.141 decimal 15 tons.
Okay. Samir, you seem to have missed. What did
144
you?
decimal point 14.
Samir, what density have you taken, Samir?
0.93, sir.
So what did you multiply? What all did you multiply? Can you just tell me what all values did you multiply?
Sir, 2.811 into 0.93 into
Very good.
into 55.
No, 55 करना था ना बेटे. ठीक है कोई बात नहीं. Thrust is equal to 144.141 tons, right, guys? Correct.
Yes.
Now we go to COP. We'll get from liquid level. Question wants from bulk at top. Question doesn't want from base this time. He wants from bulk at top, but we'll get from liquid level. We can't change the formula. COPLL will be equal to ILL upon area into DLL. You have area 55 square meters. You have DLL 2.818. Only thing is this one. Your immersed area comprises of two areas, 1 and 2. So like the first moment, the moment of inertia can also be added and subtracted. So what you can do is you can get I1LL, that means moment of inertia of area 1 about LL, and to that you can add moment of inertia of area 2 about LL. That means you can break this like this. Understood, class? Yes or no?
Yes.
Okay. Now, you will look at the diagram and you'll ask yourself a question and you answer my question. Is LL a standard axis for area 1? Yes or no?
No.
No.
No, sir.
Answer one answer is no, two answers are no. My question is
No,
LL a standard axis for the triangle?
No.
No, sir.
Is okay. Is LL a standard axis for the shaded rectangle?
Yes.
Yes.
Yes, sir.
Shaded rectangle के लिए LL is a standard axis.
No, sir.
No, sir.
Center.
Be
no,
careful,
sir,
guys. These
because it is
small
not
things.
passing through the
Yeah,
center.
yes, correct. Right. So you'll have to apply theorem of parallel axis for both, right? Correct.
Yes, sir.
Correct, sir.
XX is a axis through G1 parallel to LL and YY is a axis parallel to LL from G2. Correct, Gita? Correct. Guys, tell me, if I have to write theorem of parallel axis for I1 LL, what will I write? Tell me, guys. I'll show it later.
IXX plus
Sir,
I1XX, beta. Say I1XX.
I1XX plus area 1 into D1 LL square.
Very good. He says this. He
but
says
we can also consider base
I1XX
as
plus area 1 into D1 LL square is what he has told me. Does everybody agree with him or there is a difference of opinion, guys?
sir. We can also consider like BD cube divided by 12, like base
अरे
as
यार अब ये एरिया 1 की बात कर रहे हैं बीडी क्यूब तो कैसे
Right, sir.
like
बीडी
Right.
जैसे
क्यूब
ट्रायंगल को
बीडी क्यूब
बेस
बाय
को ले
व्हाट से
सकते हैं
लेट
सर
लेट
हम लोग
लेट लेट कंप्लीट बीडी क्यूब क्या
नहीं सर हम लोग ये ट्रायंगल का बेस भी ले सकते हैं ना सर हम लोग
आकाश
like
व्हाट
I
डिड आई
Z Z
आकाश what did I tell you when I taught you theorem of parallel axis? What is the requirement for theorem of parallel axis to be applicable? Did you sign out that time? Akash? Theorem of parallel axis to be applicable, what are the conditions?
and understood this theorem of parallel axis, but for this
Answer my
moment
question.
of
For
inertia,
no, answer my question. For theorem of axis to be parallel applicable, what are the conditions for the axis? You are not answering my question. You are just wanting to continuing your way. That means you have either
about like
not.
sir parallel axis moment of inertia about any axis is
Listen
equal.
to the question, man. I'm saying for a theorem of parallel, I'm not asking what is theorem of parallel axis. I'm asking for a theorem of parallel axis to be applicable, what is the criteria for the two axes?
One axis has to pass.
One has to be parallel to the other, sir.
That's all. Akash, you seem to have missed out the class then. Went for a walk and came in and then
It has to
suddenly.
be passes through the center of the.
No, let Akash reply. No, then he'll himself realize what he's talking. Akash, what is the criteria for two axes to be fitting into theorem of parallel axis? Oh, भाई मीटिंग में आ जा. I've called your name thrice, Akash.
Sir, sir, I lost my network, sir. So am I audible now, sir?
Yes, you're audible. What is the criteria for two axes for them to be fitting into theorem of parallel axis?
So one has to be parallel to the other one, then other one has to pass to the center of the axis.
Center of what?
Center of the center of the pressure, sir.
Center of pressure. Center of pressure तो पता ही नहीं कहाँ पर है. Center of pressure तो calculate कर रहे हैं.
Geometric center of the
My friend, you cannot be going out of the class thinking that you have understood and now you can come in any time and take up. Otherwise, you'll have these problems. And sitting at a remote location, I can tell you, from the type of questions people ask, whether they have been in the class or they have not been in the class. Because I repeated this thing at least 4 times. 4 times, Akash. And nobody in the class can miss out something repeated 4 times. कहाँ चले गए थे बीच में? आकाश किधर चले गए थे बीच में भाई? Akash, your internet is working? I think he is not getting us, so there's no point in repeating again. He'll not get it again. If he's not responding, then
sir, I lost my network, sir.
Sorry?
Sir, I lost my network, sir.
This is a normal thing. Everybody says they'll lose a network, beta. Okay.
Sir, I just joined back.
So I'm telling you, these are the normal things I get to hear. Okay. You know theorem of parallel axis, but because whatever you thought that theorem of parallel axis, you know there is no need to be there. But anyway, I see this is what upsets me the most in the class.
No, sir,
people don't want to be participating in the class. I welcome the doubts, but this, this sort of thing is something which is very disturbing, honestly. I could have answered the question and moved on. But I have to express my disappointment.
I lost my network, sir, and I was speaking and the
same
not
time now.
I was losing
I'm
my
talking
network.
about when theorem of parallel axis was being done. I'm talking of that. I'm talking of that, Bache. I'm not talking of now. I said 4 to 5 times, Akash. For theorem of parallel axis to be applicable, the two axes must be parallel and one of them must pass through the geometric center of the concerned area. Yes or no? Did you hear this statement?
Yes, sir. Yes, sir.
So, is the base passing through the geometric center of the triangle?
No, sir.
So will that fit in? Is LL, you are saying if I take this axis, is this axis and LL, will the theorem of parallel axis apply between them directly?
No, sir.
So then, something which has been repeated 5 times, if you don't want to listen to that, then I'm sorry. Sometimes, it's very annoying. How can people just... Doubts की तो कोई problem नहीं है, but when you don't want to pay attention in the class, guys, I don't take more than minimum number of classes. Believe me, if you miss out, you're missing out substantial stuff. I try to sort out the doubts. I know where are the pain points. I try to address the pain points. So it's requested that please, unless there is a dire emergency, something unfortunate, don't miss the classes, please. So COPLL, okay, is I1LL plus I2LL. Denominator is already in place. Guys, now I've opened a box bracket and I'll write the theorem of parallel axis for this expression. It will be I1XX plus area 1 into D1 LL square. This 2 is not here, this 2 is here. Correct, beta? Am I right? Yes or no? Correct, guys? This is I1LL. Anybody has... Guys, if anybody has a doubt, please let me know right now. I1XX plus A1 into D1LL square, right? Can you likewise please write down the theorem of parallel axis for I2 with another bracket? These brackets have no role because everything will be added eventually, but first time you should put brackets so that you know that this is this term, this is this term. It's very clear then. What will be I2LL? It will be I2YY plus A2 into D2LL square, right? Correct, class?
Yes, sir.
Yes, sir.
Okay. Now, once you have got this divided by A into DLL. Now, guys, look at the diagram and give me the values. How do I get I1XX? What do I multiply, divide with? Give me the values now. Don't say BD cube by this. Give me the values.
10 into 3 cube divided by 36.
Very good. Is he right, guys? Abhinav says 10 into 3 upon 36 is this term, this one. Let me use the laser. Why am I messing up? Okay. Guys, this one. Anubhav says, Abhinav says, sorry, 10 into 3 cube by 36. Is he right?
Yes, sir.
This term.
Yes, sir.
Akash, is he right? 10 into 3 cube by 36. Plus area
Yes, sir.
1 is 15. D1LL is 5. So that completes everything in the first bracket. Yes or no?
Yes, sir. Correct.
Samir, is it making sense?
Yes, sir. Correct.
Ali, how are you placed with it? Okay.
Yes, sir.
Okay. Now write the next one, guys. Write the next values. Write the next values and then compare with me. Write down I2YY plus A2 into D2LL square. Write down. You will know your mistake if you made any immediately. You will know it immediately, guys. It will be 10 into 4 cube
4 cube.
by 12 plus 40 into 2 square. Am I right, guys?
Yes, sir.
Divided by total area 55, DLL 2.818. And now you don't have to give any more explanation. You have to use the calculator on the run. Use the calculator on the run and get COPLL. How much is the COPLL you're getting, guys?
$3.844.
Okay. 3.844.
That's
Please
correct.
use your, don't start calculating each value and start writing in the answer sheet. That's whatever is on display on the screen is good enough for your answer sheet, guys. Whatever is on the screen is good enough for your answer sheet. Question wants distance from the bulk at top. Look at the diagram and answer the final question, guys. COP bulk at top. Look at the diagram. Go to the diagram.
$3.156.
नहीं बेटा 3.844 it is नहीं from the bulk at top beta. Now, are you answering COPLL or are you answering COP bulk?
7.844.
Very good.
Yes.
Guys, from liquid level, bulk at top is another 4 meters up. So from the COP is 3.844 meters below the liquid level. So from the bulk at top, it will be another 4 meters will have to be added. Yes or no?
Yes, sir.
Yes, sir.
This is the answer, beta. I don't know. Somebody was giving wrong answer. Were you giving COPLL or you're giving COP bulk at top, beta?
That was my mistake. That is a mistake. It's 7.8.
So diagram is what is going to help be handy, guys. Without diagram, if you plunge into questions, you'll mess it up somewhere. Anybody in the class has any doubts on what is on display now? You see, guys, 2 people have dropped out of the class and then suddenly they'll come with some doubt. I can see now only 42, 41 in the class. In fact, 2 of them have left the class for whatever reason. And then suddenly, when you have your exams right on your head, why you want to unnecessarily make it tough for yourself? समझ में नहीं आता मुझे. Are these 3 questions clear to everybody, class?
Yes, sir.
Yes, sir.
Yes, sir.
So first question, simple, full bulkhead immersed, single shape. Second question, single shape, part bulkhead immersed. Third question, combination of shapes. So like moment of inertia could also be added. There's no problem at all. Now we go to the next question. Guys, can you make this diagram first, please? Read the question and make the diagram. Read the question carefully. Read the question carefully. बेटा म्यूट कर लो प्लीज, म्यूट कर लो पीछे से, म्यूट कर लो guys, please mute yourself, please mute yourself, thank you, please make the diagram. Okay, if you have made any mistakes in the diagram, if you own it, you'll be able to correct your mistakes. If you don't want to own it, it's okay. And if you've not made mistakes, fantastic, guys. It's a triangle with vertex upwards. Now you'll say, sir, where do I find this bulkhead? You don't find it on the ship. It's a question, that's all. The triangle has a base of 10 meters and a height of 12 meters. Find the thrust on the bulkhead and the distance of the COP from top of the bulkhead. The tank contains oil of RD 0.93 to a sounding of 9 meters. That means the liquid level is somewhere here. Am I right, guys? Yes or no? Is this the diagram you made?
Yes, sir.
Yes, sir.
Okay. Anybody who messed it up, made it the other way without caring for the question? You have to read the questions carefully, guys. It's vertex upwards. Okay. Now, guys, what is the shape of the immersed area? Can you tell me the shape of the immersed area?
Trapezium.
Trapezium. Trapezium. Guys, this question can be done hereafter in more than one way. Somebody can take the full triangle minus the small triangle. Somebody can take two triangles and one rectangle. The easiest way, as I said, mind you, I have not said that this is the only way you can do it. The easiest for you would be to draw one diagonal of this trapezium and divide it into two areas. Then it will become combination of two shapes, both are triangle. You have just dealt with two combination of two shapes a while ago when you are doing a triangle and a rectangle. So what I'm suggesting you is the simplest of all. Naturally, if tomorrow you come across somebody who has done it differently, don't bother. It can be done in different ways. Okay, this will be 3 meters. Now, guys, this is the immersed area X. Can you please calculate X for me first by similar triangles, guys? Can you calculate X? Especially Samir and
7.5.
बेटा 7.5 तो diagram से 7.5 लग रहा है ये.
2.5, sir.
What is the height of the small triangle? Height of the small triangle is 3 meters, beta. It is not 9 meters. Height of the small triangle is similar to bigger triangle, not the trapezium, right?
2.5.
Yes. Have you realized your mistake, beta? जिसने भी कहा था कि
Yes, sir. Yes, sir. Yes, sir.
Okay, fine. X by 10 will be equal to 3 by 12. And this gives you X equal to 2.5 meters. Is that good with everybody, guys? And then you can draw any of the diagonals. I have already drawn one diagonal. Now what has it done? It has divided the immersed area into two triangles, A1 and A2. Okay, let me just, okay, guys, this is A1, this is A2. Can you please calculate A1 and give me the answer, guys? Calculate A1 and give me the answer. How much you think is A1? I don't want to show. Otherwise, you'll be tempted to unnecessarily. Tell me, what is area A1?
11.25.
11.25. 11.25.
Okay, so many people. Anybody who doesn't know how to get the area A1, please speak up. So then I'll ask you a few more questions and answer. But speak quickly if you're not able to figure out how to get area 1, guys.
Yes, sir. नहीं समझ में आया.
Okay, Durgesh, correct?
Please, Samir.
Okay, Samir. Samir, what is the formula for area of a triangle? First, tell me the formula.
1/2 base into height.
Okay, this A1 triangle, if I take x as the base, then I explain to you what will be the height. Height is the perpendicular distance of the opposite vertex from the base, correct? Correct?
Correct.
Okay. If so, I am saying this is the triangle we are talking about. If xy I take as base, then what will be the height of this triangle? Look at the diagram and tell me. What will be the distance of z from xy? Perpendicular distance. Whatever you think, speak up. If I take x as the base, Samir, what will be the distance of z from this line? Tell me.
9 meters, sir. 9 meters.
9 meters, ना बेटे ये 9 है ना, ये 9 है, right?
Yes, sir. 9.
So now can you get the area A1?
Okay, sir. I can calculate.
Calculate फटाफट. Anybody else in the class? If you speak up, then it can be addressed. Yeah, that's not an issue. Okay, Samir, did you get 11.25?
Yes.
Okay. What is area 2, guys? Area 2. Tell me area 2 also. This one. This is 2. 45 square meters.
45 meters.
45.
Okay, Samir, how much did you get?
45 meters.
45. Okay. Now, for area 1, please mark the geometric center of area 1 and give me D1LL. D1LL. Mark the geometric center of area 1 and give me D1LL, class.
3 meters.
Okay, somebody says 3 meters. I don't want to comment on it. Is he right?
3 meters.
Okay. Anybody who doesn't know that it is 3 meters, tell me. Samir? Samir, D1LL 3 meters. Is that good? You agree? Don't agree? Don't know. Which option?
Yes, sir. Agree, sir. Agree.
Okay. Guys, tell me D2LL. Mark the geometric center of area 2 and give me D2LL.
Excuse me, sir.
Yeah, tell me.
Can you show where the centroid will come? I understand how it comes, but where it will come in this figure for the area 1?
It will come somewhere here.
Okay.
It will be 3 meters from liquid level, correct? 3 meters from base, correct?
Yes, sir.
Am I right? Samuel?
Yes, sir. Yes, sir.
Okay. Now mark G2 and tell me D2LL, class.
6 meters.
6 meters.
6 meters
6
is
meters.
popular response coming from the class. Anybody who does not understand, Samuel, 6 meters good enough for A2?
Yes, sir. Understand.
Okay, now
Sir,
I'll
A2
mark
को
it.
6 meters please समझा दीजिए.
Okay, where do you think will be the job? Okay, A2. If 10 meters is the base, then what is the height of the triangle? A2 triangle, second triangle.
9 meters.
So if 10 meters is the base and height is 9 meters, then what will be the distance from the vertex of the geometric center?
Vertex okay sir. ठीक है 2/3 okay. 2/3 of
Okay.
9.
Okay, good. Okay, good. Now it's coming up. Whatever Samuel was asking, that will come up now in the class. Whatever markings were required. See, guys, if I keep showing it to you, you will not learn. You'll have to do it by yourself. That's the only way you can learn. Otherwise, for me, it's so simple. I have everything digitized. This is D1LL 3 meters. Area is 11.25 meters square. D1LL is 3 meters. Done. 9 by 3. A2 is this. Here is G2. Samuel, now you know where G2 will be. Correct?
Yes, sir. Understood.
Right. This is D2LL. This will be 6 meters. So A2 is half base into height. D2 is 2/3 of 9. We get the total area, guys. Add the 2. Can you please find out DLL now for me? Please find out DLL. We learned it in the previous question. Samir, especially you, Ali, all those people who are struggling, please find DLL and give me the answer. And if you're not
5.4.
getting it, please flag your concerns. अक्षय तुझे समझ में आ रहा है? तू
5.4
क्लास
sir.
में है नहीं है?
हाँ हाँ सर, वो
5.4 sir.
है?
साथ
चलो
ही कर
ठीक
रहा
है. Okay, very good. 5.400, right? Okay.
Yes.
Guys,
Yes sir.
Durgesh says 5.400. I don't know. Is he right?
Yes, sir.
Yes, sir. 5.4.
Okay. Anybody who's not getting 5.4 over next 15 seconds, let me know. Those who have got DLL, can you please find out the thrust? Get the thrust. This 5.400 is correct. Please find the thrust then. Pressure at GC into area.
The thrust is 281.48.
281.23.
Very good, very good, very good. Shabash, shabash, shabash. Very good. It's 282.488 tons, guys.
Okay, and that's correct.
That's
Yes
correct,
sir.
sir.
Okay. Let's take a 10 seconds pause here. Maybe some people are still lagging behind. If anybody's catching up, let them catch up. Guys, everybody is done up to thrust. Anybody wants me to wait, please let me know. Otherwise, I'll
Yes,
continue and you'll miss out. Sorry.
Please read, please read.
Okay, okay. Where are you? Where are you stuck, beta? Tell me.
Sir, I'm on thrust right now, sir.
Okay, calculate and match. You guys, you can always tell me to stop, wait. There is no hurry at all. Don't worry.
सर थोड़ा प्लीज स्लो करोगे, मतलब स्लो चलेगा थोड़ा.
नहीं, किस चीज? तू कहाँ पे है अभी? Where have you reached?
प्रेशर पे, थ्रस्ट पे.
तो करो ना कैलकुलेट थ्रस्ट.
यस सर.
स्लो क्यों चलना? अभी चौथे क्वेश्चन के बाद स्लो क्यों होना चाहिए बेटा?
फास्ट हो रहा है सर, लेकिन चलेगा.
Unless you are using the same phone and phone calculator. उसी पे स्क्रीन देखना, उस पे कैलकुलेट करना है, फिर तो टाइम लगेगा ना. Guys, those of you who are logged in through phone, my advice is that except for emergencies, please log in from a desktop or a laptop. The screen size makes a lot of difference to learning. So please avoid logging in through the phone. फोन पे वो नहीं सीख पाओगे, इफेक्टिवनेस नहीं आपकी बेटा. इट्स अ टेस्टेड थिंग दैट आई एम टेलिंग यू. ओके, एवरीबॉडी इज डन विद थ्रस्ट नाउ. अब बताओ भाई, किसको वेट कराना है? और हाँ भाई, हो गया थ्रस्ट अभी?
ओके सर, हो गया.
Okay, done. Okay. Now, guys, COPLL will be ILL upon A into DLL. You can't change the formula. Whether he wants from bulk at top, he wants from bottom, doesn't matter. You can't change the formula. And when there are two shapes or three shapes, what will you do? You'll add the moment of inertia of all the three, 1, 2, 3 shapes, right? So I1LL plus I2LL. Guys, now you'll understand why I asked you to do more formulae for the triangle. Now, if you had done only one formula, PD cube by 36, then you would have been forced to again apply theorem of parallel axis. Look at area 1, guys. Is liquid level a standard axis for area 1? Yes or no?
Yes, sir.
Which formula?
BD cube upon 12.
BD cube upon 12. Very good. Okay, somebody who was lagging behind, कौन था? समीर था? कौन था who was lagging behind? I missed out seeing the name. Who was that, guys? कौन था बेटा? Somebody was lagging behind a while back when we were calculating thrust, so that I can address him now and check.
समीर था, समीर. ओके सर.
Okay, now guys, look at area 2. Is liquid level a standard axis for area 2? Look at the diagram, guys, and tell me.
Yes, sir.
Oh, sir.
Yes, sir.
If you are saying no, you can apply theorem of parallel axis. I have nothing against it. But tell me, is it one of the formula fits in directly? Then you'll save time.
Yes, sir.
Yes,
Which
sir.
one?
BD cube by 4.
Vertex on BDQ upon 4.
BD cube upon 4. Those who said no, have you realized that BD cube upon 4, LL is passing through the vertex of area 2 and parallel to base? Yes or no?
Yes, sir.
हेलो.
Right, guys? So you can
हाँ.
apply those two formulae directly
अरे
and run
आओ
away with the
लेक्चर
question,
मचे.
saving at least couple of minutes here.
હા. તમે કાં છે? પહોંચી ગયા. બેહેલા છે. હારું આવો.
Question is on display now. Let me know. Complete it. Don't copy it from the board, guys. See, this is why I asked you to learn a few more formulae here and there so that questions become easier to handle. But if you still want to use BDQ by 36, then you'll have to apply the theorem of parallel axis for I1 and I2 like we did in the previous question I had done. Okay. Is everybody happy with this question, guys, or anybody still doing it? Let me know, guys. Samir, done, beta?
Yes, sir, done.
Guys, there is one question I'm giving you for homework. That is this question. Next one. And I'll put this is the same question which was there. This I have done. See, here I have done by theorem of parallel axis. Some of you may wonder why the same question is being repeated. Here I have done by theorem of parallel axis, right? You'll get the same answer, correct? So here I did not use those formulae through base and through the vertex. I used theorem of parallel axis through G1 and G2, right, beta? Anyway. Okay. Okay, guys, this question 980 point. I'll put the answer in the on the thing. Have I answer is already there now? Why I have to put it? Can you open this the questions that I've sent you guys? This is question number 5, middle one in the bottom line, bottom row. And answers are there 980.101 and COP bulk at top 7.566. Guys, would you like to try this question at home and see that you're able to do it? I have the solution, but I don't want to show you.
Yes, sir.
Is that okay?
Yes, I will try.
Okay. The last question, you leave it. We'll discuss it tomorrow. So guys, I sent you 6 questions. Out of 6, 4 we have discussed in the class. 5th one I am giving you as a homework. So what do I expect you to come prepared to do today? One is question number 1 from prior learning. Hint I have already sent you guys. Please complete this. You can share the answer. Don't ask me the answers. I don't keep answers because I've given you hint there. You can share on the group, guys. Then question number 5, COP geometric shapes, regular geometric shapes. Okay. Then, guys, those of you who have done phase 1 a while back, please revise Simpson rule 1 and 2. We'll be using them tomorrow for curvilinear shapes. So if you glance through them, especially those who have done phase one a while back, you will be able to connect faster. What do you need to see here? What is the applicability criteria for each rule? When is rule 1 applicable? When is rule 2 applicable? Only 1 and 2, not 3. Then what are the Simpson's multipliers? What are the coefficients? How do we get the final result formula? And also, guys, besides this, how do we get levers from reference axis? How we get moments, and how we get the geometric center of area, like center of flotation and all that you did in phase one, geometric center of area. Have you understood the scope of revision for Simpson's rule, guys, which you need to run through? This will help you in better understanding tomorrow. So, and all this that I've given you, it may have filled up my page, but you believe me, to you, this will not take more than an hour, hour and a half, the entire thing that we are talking about on this sheet. One question, 15 to 20 minutes. Question number 5, 15 to 20 minutes. That means about 40 minutes go out here, and remaining about 50 minutes or 1 hour, you can run through your Simpson's rules because you have done them extensively in phase one. So it's nothing new. It's a revision of what you know. Tomorrow, what I'll do is, if anybody has a doubt in question number 5, I'll address that. If all of you get the answers, I'll not even show you the solution, because if you get it, then that is the best thing I can expect. Then I'll close out the last question from this list that I have shared, and then we'll move on to COP for curvilinear shapes. COP for curvilinear shapes, we'll move on to that tomorrow. In all probabilities, I'll finish off COP regular curvilinear shapes tomorrow. Okay, so that is my agenda. The COP business will continue over next 3 classes, guys. Tomorrow, day after tomorrow, then Monday, of course, the classes are not there, and Tuesday. So total 4 classes, this moment of inertia and its application will take. So we'll complete it over a period of 4 sessions. And in that, it will give you enough chances to apply theorem of parallel axis, deal with the regular shapes, deal with the curvilinear shapes. It will keep happening every day over next 3 more days. So don't worry, even if there is some apprehension in your mind, this is the same topic is continuing. So it's going to sink in well, don't worry. And guys, one more, the last request before I sign out for the day. Guys, I'm open to slowing down. I'm open to addressing your doubts, but it has to be reciprocated by effort. It cannot be a makeshift, connection whenever you want to come in, because that will break the rhythm. Okay. And things which are important, I don't wait for you to make mistakes, because I know if you make mistakes, that will shatter your confidence. The whole idea of telling you certain things upfront, like for example, for theorem of parallel axis, when I said for it to be applicable, these conditions must be fulfilled. So the idea is that when you reach there and you can say, no, theorem of parallel axis will not apply, that will boost your confidence. On the other hand, if I start holding things up my sleeve, I just define theorem of parallel axis, and then I'm not here to establish that you don't know anything and I know everything. No, guys. I want to share as much as I can so that when you go to application, you should have the confidence in your own self. Please remember that, and that is the only thing that is going to see you through in the exams. And what you need to do is plan your ship construction the way you want to plan. Stability, I'll take care. Ship construction, you can plan the way you want to plan it. And rest will, stability part, you don't have to worry much. Whatever little I'll give you for evenings, that will be very little. Most of it will be covering in the class. Okay, beta? Okay, guys?
Yes, sir.